So good morning, grade 12 students. In this video, we're going to continue or to complete our genetics chapter, and to be more specific, in chapter 5, document 4, chromosomal mutations on your book, pages 98, 99, and 100. So here we talk about the chromosomal abnormalities. We said that they are classified into two categories, either regarding the number, which is called chromosomal numerical abnormality. This chromosomal numerical abnormality it affects the number where we have either an additional chromosome or a chromosome less, or we have chromosome more than the normal or chromosome less than the normal. These are detected using the karyotype, which is a range set of the chromosomes. They are arranged in decreasing order of size, position of the centromere, and the banding pattern. Whereas another category is the chromosomal structural abnormality, where the structure of the chromosome is abnormal. We have translocation or we have missing a part of the chromosome, like the case of Crater syndrome. So here, chromosomal numerical abnormalities, they affect the number. Maybe they are an extra chromosome or a missing, like for example, a trisomy or tetrasomy or Klinefelter syndrome, or there is a missing chromosome, like the case of monosomy and the Turner syndrome. Also, we said the karyotype, you have to know the chromosomal formula. If I ask you for the chromosomal formula, always and always and always, the chromosomal formula, 2n equal 46, this is the normal one. So 2n equal 46, this is the normal, where we have 2n equal 46 chromosomes, and we have the sex chromosomes, for example, XX or XY. It depends on the case. For example, we have an additional chromosome, so addition it will be 2n plus 1, so it will be 47, comma, and you put the sex chromosome, whether XX or XY, or maybe it's XXY, or we have a missing chromosome, so 2n minus 1 equal to 45, and then you put comma, and you put the sex chromosome XX or XY, or maybe we have an X only, which is Turner syndrome, which is X, and you put this X and you put O. This is related to the chromosomal formula. So you have to know the chromosomal formula, because I'm going to ask this in the coming quizzes. So we have monosomy or trisomy, or we have Klinefelter syndrome. We said that the Klinefelter syndrome is going to be sterile due to the abnormality or the abnormalities at the level of the gonosomes, which are the sex chromosomes. Also, we have chromosomal structural abnormality. It affects the shape of the chromosomes or more than one of the chromosomes. It's a translocation or a missing part. So we have translocation. It's translocated from one pair to another pair, or it's deletion or a missing of one of the parts of the chromosome. This can be detected, as I said, by karyotyping. So books, you move to the books. We said that in document B here. In document B, we said that as the material age increases from 35 to about 43, the frequency of the Turner syndrome it increases. Here we said slightly, so to reach about 3 or 2.8% for the frequency of the Down syndrome, while as the mother's age increases from 44 till 46, so the frequency it increases sharply to reach about 8%. So as the age of the mother increases, the risk or the percentage for the Down syndrome will increase, and it will increase the chance for having a child affected with Down syndrome. Also, we move to the Down syndrome properties. Sure, you don't have to study these, only you have to know we have abnormality, and you have to know that XXY is called Klinefelter syndrome. Also, regarding the Klinefelter XXY, affects the males who are sterile due to the atrophy of the testes. So they exhibit both male and female secondary sexual characteristics. They have, for example, abnormal development of the breath, and mostly they have and often they have the mental retardation. So we tell them about the Turner syndrome. This is the karyotype of the Turner syndrome. Turner syndrome here X, so you have a missing sex chromosome. So here we have the Klinefelter, and we have XXY. Okay, so here from now on, karyotype is important to detect any abnormality. Also, we move to talk about the causes of abnormality. Mostly, we said that the abnormalities in the chromosome number, they are usually due to errors in meiosis during the formation of gametes. This process, we call it gametogenesis. So we have a non-disjunction of the homologous chromosomes, leading to the formation of gametes that carry a copy, both copies of chromosome, and a copy or a gamete that carry lack a copy of these chromosome. So this union by the process of fertilization, the union of the male and the female gamete, either leads to the production of a a copy or a karyotype that have a higher number or a chromosome that are by increasing number or extra chromosome, or by a karyotype having a missing chromosome. This will lead to the, in case of extra chromosome, we have trisomy, we have Klinefelter syndrome, or for example, in the case of the missing chromosome, we have the monosomy, or we have the Turner syndrome, which are the abnormality affecting the structures. In the case, as I said before, the case of Cri-du-Chat with a pair of chromosome number 5, where we have, in this case, we have a pair of the, or a portion or a segment of the chromosome that is missing here. So this portion that is missed here, this is responsible for this disease, Cri-du-Chat. The Cri-du-Chat is called the cat's cry syndrome. So we solved the exercises, we compared, and we talked about the Robertsonian translocation, where Robertsonian translocation is 2114. So we have translocation from the chromosome number 21 to chromosome number 14. This is called Robertsonian translocation. The third copy, where the copy of chromosome is attached to the chromosome number 14. So you have to remember these notes. Also, we said that the frequency of the Down syndrome is directly proportional to the maternal age. So as the maternal age increases, so this will lead to the increase in the frequency of the Down syndrome. So كل ما زاد عمرها للفيميل كل ما زادت chance or the risk for having a child having Down syndrome. Also, we said about the chromosomal formula. You have to know this and you have to study how to write the chromosomal formula. First of all, if we have the chromosomal formula, so 2n, for example, equal 46, comma, xy, this is, or xx, this is the normal case, or xx. Sure, in the exam, you don't have xx or xy. You write it according to the given karyotype. If you have a missing chromosome, like in the case of Turner syndrome, so 2n minus 1 equal to 45, comma, you write what? You write XO or X0. So this is, we have a missing sex chromosome, and this is sterile due to the abnormality at the level of the sex chromosomes. Whereas the Klinefelter syndrome, it's 2n plus 1. Why? We have an additional chromosome, and the number of chromosomes is going to be 47, since we have an additional chromosome. This is logical. And comma, XXY. So we have here X chromosome, they are XXY. This is a sterile individual due to the abnormality at the level of the sex chromosome. This individual has is a male for sure, since it carries the Y chromosome, but it has feminine characteristics and male characteristics as well. So this individual is developing abnormal development of breast, and for example has atrophy of the testes, and it has a sterility problem. So this is everything related to the chromosomal formula and related to the abnormalities in the case of karyotype. From now on, any question related to the karyotype is going for sure related to the gel electrophoresis, band, thick band, thin band, and so on. So you have to do this and you have to be familiar with these questions. So we move to the prenatal diagnosis. This one that we didn't finish the last week, prenatal diagnosis. So we said that prenatal diagnosis is the one that occurs before birth. That this technique allows us to predict and to detect, both of them, prediction and detection of the presence of genetic disorder. This genetic disorder, maybe it's going to be hereditary one or it's a congenital one. So this will be detected in the fetus before birth for sure. We said we have three methods to detect these diseases or these abnormalities. First detection is called amniocentesis. Second one, chorionic villus biopsy. And third, fetal blood cells sampling. We said that amniocentesis is the extraction of the fetal cells that have sloughed off the fetal skin. This process can be performed starting the fourth week, fourth month of pregnancy, يعني بعد 4 أشهر in pregnancy. And chorionic villus biopsy, we said that we have extraction of the fetal cells from the chorionic membrane of the placenta. Here is the placenta in this region. So here we have chorionic villus biopsy. We have extraction of the fetal cells from the chorionic membrane of the placenta in this region, and it takes place starting from the 8th week of pregnancy and about even 2 months. And then we have the last one, it's fetal blood sampling. It's abbreviated as FBS, fetal blood sampling. So we have insertion of a syringe into the blood vessels of the umbilical cord as shown in this figure, and this can be performed starting from the 20th week of pregnancy. So here are the methods. Analysis of the fetal cells. Analysis, we have karyotype analysis. Karyotype analysis, this will allow the detection of abnormalities of the chromosomes. So we have a possible chromosomal abnormality. It can be detected using the karyotype. And we have genetic fingerprint. We said, why do we say it's the genetic fingerprint? Because its fingerprint is unique for each individual. So genetic fingerprint is going to be unique, and it allows the detection of hereditary diseases on the genes. Also, we have biochemical analysis. This will allow to a detection of the proteins or enzyme alterations, or we have deficiency in the enzymes. DNA analysis, and this where we stopped the last time. Here, DNA analysis. First of all, what do we did? We have DNA of the fetal cell, and then we did fragmentation of the DNA using restriction enzymes. Then we move to the gel electrophoresis on an agarose gel. Then we have transferring or the plotting on the nitrous or the cellulose filter. Then we did hybridization using P32, and then we have the washing. This hybridization led to be auto, it will be, for example, fluorescence, and we detect autoradiography, and we have this the degree showing the heterozygous mother, heterozygous father, and showing the fetus, where we have both mutant allele and normal allele, and the fetus result. So I will ask for Selena. Selena, I want from you to describe this experiment, please. Yeah, describe. Okay. First of all, describe, Selena. What do we have to use? We have to use the passive voice. So you don't have we got a DNA, we fragmented, we transferred, we watched. You have to say DNA fragmentation using restriction enzyme was done, and so on. Okay, Selena, it's yours.
DNA fragmentation of a fetal cell was performed using restriction enzymes.
Okay, sure. First of all, you have to say DNA of a fetal cell was fragmented. Okay?
Oh, okay.
Okay, yeah. Let's continue.
Um, and then electrophoresis was performed
Uh,
on agarose gel.
Very good.
Uh, then it was transferred or blotted
Okay, on A,
nitrocellulose filter.
exact,
Then it was hybridized
hybridized, excellent, using P32.
and then washed to give us an autoradiography.
Okay, thank you. Thank you. Moving to Hassan Watfa. Hassan Watfa, looking at this autoradiography, we have these bands. So we have the mutant allele S and the normal allele M capital for the mother, the fetus, or the father. First of all, I want from you to know that both the mother and the father, they are normal. Both of them, they are normal, and they gave birth to the fetus. Fetus, they have the risk of having, for example, a disease, or it's a mutated or affected fetus. Can you tell me the results? What happened here? Explain the results for the mother and the father, as well as that for the fetus. Yalla Hassan.
First of all, mother and father has NS genotype.
Okay, first of all, you don't have to give the genotype immediately. So pay attention, all of you, and Hassan as well.
Okay.
First of all, you have to talk
The
about the bands. Whenever you talk about the bands, you have to move to the genotype. So you have to detect the genotype using the bands. Okay, Hassan?
okay.
Yeah, start.
There is two normal parents gave birth to affected fetus.
Affected fetus. First of all, Hassan,
We,
you detected that the fetus is affected, and you said that the parents, the mother and the father, they are normal.
mm,
How?
from the bands they
Okay,
have
first
the
of all, you
parents
have
they
to talk
have.
about the bands, Hassan. So you have to say
Okay.
father and mother, both of them, they have two bands in the mutant and the normal. So both of them, they are normal regarding the disease, while they gave birth to the child
birth.
that have one. شو بدنا نقول هلا about the band.
One thick band
Excellent,
on the.
excellent. Pay attention here, all of you. One thick band. So this is an important word to say. One thick band in the mutant allele. So it has two SS, for example. So it's affected 100%. So this explains that the fetus is going to be affected or normal
Affected.
since it's homozygous for the mutant allele. And the mutant allele in two copies. تبعنا كلنا؟
Okay.
Okay, Hadil, clear?
Yes.
Okay, Rama, everything is clear till now? Rama, عم تسمعينا? Do you hear me? I think Rama went. Summer, everything is clear? Yes, Summer,
Yes, yes.
everything is clear?
Uh,
Okay, great. Yeah, so let's continue. Open your books on page 101 and 102. So prenatal diagnosis, the presence of a genetic disorder in a family is an indication for a couple to consult a physician who asks for a specific test to predict the risks. What are these tests? When and how are they performed? So as I said, the methods that are used in the prenatal diagnosis to perform a biomedical analysis of the fetus, it's necessary to obtain a sample of the fetal cells. This can be performed by three methods that we said about them. Amniocentesis, this is the first method, amniocentesis. Amniocentesis, which is a sampling of the amniotic fluid. This contains the cells that have sloughed off the skin of the fetus. This procedure may be performed starting around the 16th week of pregnancy. While the second method is the chorionic villus biopsy. This is the second method. Second method, it's sampling of the chorionic cell. The chorion is the fetal membrane whose cells have the same genetic makeup as the fetus. This can be performed starting the week 8 of pregnancy. While the third method, which is the sampling of fetal blood, which is fetal blood sampling, it's the withdrawal of the fetal blood from the umbilical cord. This can be done starting from the 20th week of pregnancy and starting from week 20 of pregnancy. So here we have three methods. You have to know these three: amniocentesis, chorionic villus biopsy, and fetal blood cell sampling or sampling of the fetal blood cells. Okay, guys? So these are the three methods. Moving now to this. Here we have fetal blood cell sampling, which is A, B, and C, DNA analysis, and we have the karyotyping, and all of them, they lead to the C. Analysis of the fetal cells. Fetal cells, they are cultured, and then they are submitted to different tests. One of these tests is called the karyotyping analysis. This is analysis of the karyotype. Karyotype analysis, it allows the detection of the congenital chromosomal abnormality. Or fetal DNA analysis. Fetal DNA analysis using the radioactive probes for the detection of specific abnormal genes. They use radioactive probe that's complementary and it's radioactive. And third, we have the biochemical analysis for the detection of the protein or enzyme alteration or deficiency, like the case of hemoglobin, for example. So here, document B, it shows the different step of the DNA analysis performed on members of a family that are the father, the mother, and the fetus that we explained before. The homozygous or heterozygous state of the fetus is thus revealed by the gel electrophoresis. So here we have DNA fragmentation using restriction enzyme of the DNA of the fetal cells. Then we have gel electrophoresis on the agarose gel. That's called gel electrophoresis. And we have transferring and blotting on the nitrose filter and hybridization with radioactive probe P32. And then we have washing, and then autoradiography that shows the results. So here I'm going to move to the probing the documents on your book on page 102. And this should be done and should be copied on your copybook and should be written by today. So these notes, these probing the activity and also related to the prenatal diagnosis, this should be done by today. So probing the documents on page 102. If a therapeutic abortion is to take place, do you know what the meaning of abortion? We talk about this in chapter 15 and it's related to chapter 16, even though the chapter 16 is cancelled for this year. What the meaning of abortion? Do you know what the meaning of abortion?
To
Yes?
get rid
Yes.
of a fetus.
Excellent. To get rid of the fetus. يعني هيدا بيسموها بالعربي تكون فيميل إجهاض أو سقطت الفيميل. Okay? So it's if a therapeutic abortion is said to take place, which one of the three prenatal diagnoses the best? Justify your answer. This is the first question. Part two, we want to specify the genotype of the family studied in document B. Part B, what advice can the doctor give to this couple? شو بيعطيهم الدكتور advice شو بينصحهم. Part 4, we are going to describe the experimental procedure. Part 3, what is the importance of the prenatal diagnosis? Already we talked about this. So we're going to start with the first one. So which of the prenatal diagnosis is the best? Justify your answer. Chorionic villus biopsy is applied starting from the week 8, which helps us to detect the abnormality. So this will make the abortion more safe. As you know, we have how many techniques? We have 3. We have chorionic villus biopsy, we have the amniocentesis, and we have the fetal blood cell sampling. In order for abortion to take place and to be more safe, the child should be, for example, elder or younger. So it should not, for example, wait for the 8 months, for example, let's say, and to make abortion. This is a risk for the fetus life and for the mother's life also. Okay, so here let's say which one is the earlier one. يعني أي واحدة هي فيها, for example, to start with this. So here we move to the techniques. Techniques, first technique is the amniocentesis. It starts for where? It starts from 16th week of pregnancy. Chorionic villus biopsy, 8th week. While the last one, sampling of blood cells, is done from the 20th. So which one starts earlier? Starts earlier, this one, the chorionic villus biopsy, and this will be more safe for the mother. So هتكون أكثر أمنا, or for example the best one for the mother. Even though to start to wait for 16th week or to wait for 20th week, it's a dangerous one and it has a high risk on the females or on the mother's life. Okay, that's why we chose the chorionic villus biopsy. So restriction map of the father and mother, they showed 2 bands, N and S. So genotype, as مثل ما قال لي حسن, their genotype should be NS. While restriction map of the fetus, it shows 1 thick band. Here, if you said 1 band, it's wrong. You have to mention this word, thick. 1 thick band S. So their genotype is going to be SS. So it's sick. You can say it's affected if you want. It's up to you. It's affected since it's homozygous for the mutant allele. So what advice should the doctor said or give? The abortion of the fetus is advised. يعني بقول لهم اعملوا له abortion. هلا بتيجي بتقول لي دينيا or whatever, it's not my case, it's not my issue. Okay? So this is related to the science. The abortion of the fetus is advised. So this is part number 1. So as they said, which one is more safe? More safe هي اللي تاخد, it starts at earlier time. So chorionic villus biopsy تبلش at week 8. بتيجي في منهم amniocentesis week 16, while the fetal blood sampling starts at week 20. So the earlier one, it's the one that is called chorionic villus biopsy. Restriction map, partitioning 2 map, 2 bands for mother and father, N and S. So both they are heterozygous having genotype NS, while that of the fetus, it shows 1 thick band. So genotype is SS, so it's affected or it's sick, homozygous for the mutated allele or the mutant allele. And part B, what advice should the doctor give? Abortion of the fetus. Moving to part 4, that already we explained it and we solved it. At first, DNA of the fetus cell is taken. This DNA is subjected to fragmentation with restriction enzymes. Then the DNA gel electrophoresis is done on agarose gel, and DNA is transferred to an aerosol filter by clotting. cDNA is added on the nitrocellulose filter, so hybridization of the DNA takes place, or you say, and then hybridization took place. This is followed by washing of the nitrocellulose filter. Autoradiography is done. Two bands for the parents are absorbed. One thick band for the fetus is absorbed. This is everything for our session for today. Here we finished everything related to chapter 5, documents 4 and 5 about the chromosomal abnormalities and about the, uh, the prenatal diagnosis.